Look at this room. This room is so neat and tidy. Everything is so neatly placed in this room. Now, if no one was to enter this room or disturb an object in this room, would they move by themselves? Obviously no. So what can we conclude from this? Well, we can conclude that an object at rest stays at rest if left undisturbed. They would not move by themselves. But what about moving objects? Let's see. Well, if we move this ball, that is, we kick this ball, what do we notice? We notice that it has a tendency to come to rest after a certain time. So, moving objects have a tendency to come to rest after a certain time. Based on these two experiments, we can conclude that rest is the natural state. All objects tend to come to rest after a certain point in time. Scientists believed in this notion of rest being the natural state for thousands of years before they were proved wrong by another scientist named Galileo. Galileo agreed that an object at rest stays at rest if left undisturbed. But he did not agree that a moving object has a tendency to come to rest. Instead, he said that an object in motion continues to be in motion with the same velocity if left undisturbed. That is, a moving object would never stop until or unless a force is applied to it. Now, this doesn't seem that intuitive. So, let us perform a small experiment to validate this. Here, we have three different surfaces. Surface 1 is made of grass, surface 2 is made of ice, and surface 3 is a special surface. We will try to roll a ball on each of these surfaces by applying an equal force. Observe what happens. Well, you notice that the ball moves a greater distance in surface 2 as compared to surface 1. And in the case of surface 3, the ball keeps moving with the same velocity indefinitely. Now notice that the ball does not stop immediately after you kick the ball. That is, immediately after you withdraw the force from the ball doesn't automatically stop. It moves a certain distance before stopping. So, force is not exactly required to keep the ball in motion. The ball can continue to move even when you are not applying a force onto the ball. So what stopped these balls on surface 1 and surface 2 eventually? Well, the ball stopped because all surfaces exert a force onto an object placed on them. This force is known as the frictional force. And this force opposes the motion of the object. So even when we cannot observe any force acting on the ball, there is a frictional force acting on the ball which is in the opposite direction of the motion of the ball. Now, why was it that the ball moved a greater distance on surface 2 as compared to surface 1? This is because the frictional force acting on the ball on surface 2 was less than that of surface 1. Hence, the ball on surface 2 was able to move a greater distance as compared to surface 1. Now, what about surface 3? I had mentioned that surface 3 is a special surface. Surface 3 is prepared in such a way that it is frictionless. That is, it does not exert any friction of an object placed on it. And what did we observe for surface 3? We observed that the ball kept moving with the same velocity indefinitely. So, we can conclude that an object in motion stops due to the presence of a force and not due to the absence of a force. The force over here was the frictional force which was making the ball stop. if there was no frictional force, as in case 3 or surface 3, the ball would have kept moving with the same velocity indefinitely. Newton summarized these observations in his first law, wherein he stated that an object at rest continues to be at rest and an object in motion continues to move with the same velocity unless an unbalanced force is applied to it. So what can we conclude from this? We saw that in order to make a resting ball move, we had to apply force. Further, in order to make a moving ball stop, there was some force involved, the frictional force in this case. So force is required to change the state of motion. To make a resting ball move, we need force. To make a moving ball stop, we need force. Hence, force is the cause of change in state of motion. Further, by making a resting ball move or a moving ball stop, we are essentially changing its velocity. So force is the cause of change in velocity. And since change in velocity is simply acceleration, force is the cause of acceleration. Now, what does the direction of force have to do with acceleration? Observe something here. When the direction of force is in line with the direction of motion, that is, when we kicked the ball in this direction, we saw that the velocity of the ball increased from 0 to a positive value. So what can we conclude about acceleration? Well, acceleration was positive in such a case. Now what about the second case, when friction was acting on the moving ball? Since friction acts in the opposite direction of motion, we noticed that the frictional force reduced the velocity of the object. Hence, the acceleration was negative in this case. So when the direction of force is in line with the direction of motion, acceleration is positive. And when the direction of force is opposite to the direction of motion, the acceleration is negative. Now notice, we have written that force is the cause of change in velocity. Now change in velocity can happen due to change in speed or change in direction. So we've discussed about speed here. Also, there is the possibility of change in direction. So force need not always change speed. Force can also just change the direction, or it could change both speed as well as direction. So for example, in a football game, when the striker deflects the ball into the goal post, he might just change the direction of the motion of the ball, or he might change both the speed and direction of the ball. In both the cases, it is the force exerted by the striker on the ball which is making the ball move into the goal post. Further, what happens when we pull a rubber band? We know that pulling is a force. So when you are exerting force onto the rubber band, the shape and size of the rubber band changes. So force can also cause change in shape and size. So force causes change in state of motion. Change in state of motion can be change in speed, change in direction, change in shape, or change in size of the object. So to conclude, Newton's first law states that an object at rest continues to be at rest and an object in motion continues to move with the same velocity unless an unbalanced force is applied to it.